Good morning, everyone. Today we are going to learn about a new topic, circles and lines. Okay, let's start with an interesting one. Have you seen Ferris wheel before? Yes, here is an image of Ferris wheel. We are going to define a circle from this. So you have to observe the Ferris wheel. Okay, just observe. Have you recognized that the bogies of Ferris wheel are equidistant from its fixed point? Have you recognized? We are going to define circle from this sentence. Okay, let us consider each bogies as points on the boundary. Okay, and each are equidistant from a fixed point. So how we can define a circle? Let's change fixed distance as radius and fixed point as center. So how we can change the sentence? Set of all points which are equidistant from a center. Okay, let's define circle as a circle is a closed two-dimensional figure in which the set of all points in the plane is equidistant from a given fixed point called a center. Have you understood the meaning? Can you suggest some examples for a circle shape from your daily life? Just write it down on your notebook. I hope the content is clear for you. Let's move on to another section. In this video, we are going to study about parts of a circle. The parts of a circle are radius, diameter, chord, and center. Let's study the definition of all of these. The first one is radius, and the radius is defined as the distance between the center of a circle and any point on the circle. And the second one is diameter. Diameter is a line segment passes through the center and its endpoints are on the circumference of a circle. And the third one is chord, the line segment joining any two points on the circle. And the fourth one is center. And the center is defined as the point inside a circle that is equally spaced from all other points on the circle is considered as the center of a circle. Now we are familiar with the chords. Let us study the properties of chord. For that, I am drawing a circle and using the segment tool, next I am drawing a chord inside a circle. Next we are going to draw the perpendicular bisector for this chord. I am using the perpendicular bisector tool from the more option. Here is the perpendicular bisector of the chord CD and it is passes through the center of the circle A. By moving the chord, the perpendicular bisector doesn't change the path through the center of the circle, which means the perpendicular bisector of all the chord passes through the center. Let us verify with one more chord. I am drawing another chord EF and perpendicular bisector to the chord and it is also passes through the center. This is our property. The perpendicular bisector of all the chord passes through the center of the circle. Next, we are going to study a second property of a chord. For that, I am drawing a circle and some number of chords of different length at a different distance from its center. As the chord move away from the center, what happened to the length of the chord? Let's take an example. Let's take the chord CD and chord GH. The chord GH is much closer to the center of the circle than the chord CD, and also the length of the chord GH is larger than the chord CD. From this, what we can conclude? We can conclude the length of the chord decreases as it moves from the center of the circle. This is our property. We have covered the definition of circles and its parts and various properties of chord. Let us go through a beautiful story of triangle and circle. The exchange of letter. One day, the triangle was decided to meet all the shapes those were playing on the ground, and all the shapes were playing their own games in their small groups of friends. So the triangle constructed a small game of properties to play with them. Everyone joined with triangle and the triangle explained the game. The game was each one should tell their properties when their turn comes. All the shapes started the play. At the first round, the circle could not find their property. The circle became very sad and moved away from them. The triangle came to help the circle with a letter, and the letter was the perpendicular from the third vertex bisect the base. The line joining the third vertex and the midpoint of the base is perpendicular to the base. The circle couldn't understand the meaning in just one read. Circle puzzled at first, but as the moon rises, she translates the properties. At last, Circle created an isosceles triangle inside her by joining the endpoints of a chord to its center. And then she realized that replacing the third vertex as center and base by chord, respectively in the letter, will change the property of triangle to mine. On next day, the triangle reached their gang and showed her property. Each of them appreciated the circle. The circle said thanks to triangle and they become best friends. going to learn how to construct an equilateral triangle inside a circle. We have already studied a method before, and this is another one. Let's move on to the construction. Okay, and this is an application called MathPad, and you can access it is accessible from the Google. You can try it on. And first you have to take your scale and a compass from your instrument box and take 3 centimeter on compass and draw a circle. Then draw any radius as your wish. From this radius, we are going to mark a point which is at 120 degree from this radius. Okay, for that we are taking a protractor and place it over the radius. Make sure that the lines are coincides very well. Then mark the point at 120 degree. Then join the new point and center. So we get a new radius, isn't it? From this radius, we are going to again mark a point at which is at a 120 degree away from the second radius. Okay, for that we are taking the protractor again and repeat the same process. Then third point to the center. So we get a new 3 points, isn't it? Then we are going to join the 3 points. First we have to we are going to join the first 2 points, then the second 2 points, then the last 2. Okay, I think you got a triangle. Let's check it whether it is equilateral or not. So for that we are taking the protractor again. We know that one angle of equilateral triangle is 60 degree. So we are going to measure it with the protractor. Place it like this. As you can see, it is 60 degree. And let's try on another vertex. It's also 60 degree. Then obviously the third vertex, third angle will be 60 degree. So we get an equilateral triangle. This is another method. You can also try the method that we previously studied. I think you understood the method well. Thank you.